Alright, we're very quickly going to go through section 4.2 here, ways to prove triangles congruent. And the first way to prove triangles congruent would be our side-side-side postulate, which says if three sides of one triangle, like these three, are congruent to three sides of another triangle, like these three, then the triangles are congruent. For example, if I had a picture like this, you might ask, do we have congruent triangles here? Well, I only see two sides marked congruent. However, they share side AT. So if we pull that off, we've got three sets of congruent sides, and a proof might say that AP is equal to AR, which is given, PT is equal to RT, which is given, and then AT is equal to itself, which is reflexive. Now, normally I could also just say that segments are congruent. It just saves me time typing to put in that the lengths are equal. And that's side, 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 and those three sets of sides gives me side-side postulate. Notice when I name the congruents, I go in order. PAT, RAT, because P corresponds with R. So we got to start with the right ones. So before we go on, we have to talk about included angles and included sides. An included angle is the angle between two sides. So if I look at this first picture and I have these two sides marked, the angle included between the two is the one that is made up by those two sides. So that's angle G. The side included between these two is angle I, and the last two, angle H. So between YE and ES, we'd have angle E. Between ES and YS, we have angle S. And between YS and YE, we have angle Y. That's included angles. Now I'm going to skip this one here and go on to included side. The included side, when we have two angles marked, is the side between those two angles. So if I have two angles being used in a proof, I might say, all right, well, the side included between them is right here. Side that makes up one of the sides of both angles. So this one, GI is the included side. The next one, that's right, HI is the included side. And the last one, GH is our included side. So between Y and E, those two angles, we have segment YE. Included between angle E and angle S, segment ES, and between S and Y, we have segment SY. The side angle side postulate says, and that's SAS, if two sides and the included angle of one triangle, like this, are congruent to two sides and the included angle of another, which looks like this, then the triangles must be congruent. So for example, if we had a picture here, we might say, do we have congruent triangles? And you would say, well, I only see two sets of sides marked congruent. I don't see anything else. And someone else, a little more clever, might then say, well, the triangles have congruent angles. 1 and 2 are vertical. So we have the given, again, those two sets of congruent sides. And then we say angle 1 is equal to angle 2 because vertical angles are congruent. We have a side, and an angle, and then what we have to do is ask ourselves, is that angle included between the two sides? And it is. So when we write the congruency, we put it side, then angle, then the side. And again, we pay attention to the order that we name those triangles. Next, the angle side angle postulate says, which is to say, if two angles and the included side of one triangle, like this one here, are congruent to two angles and the included side of another, then the angles must be congruent. So again, this is two sets of congruent angles and the included sides being congruent, the sides in between those angles. Example. Given AT is equal to YT and angle A equals angle Y. YP is congruent to AR, or YP is equal to AR. Well, that would be easy to prove if I had congruent triangles. And looking at this, using angle 1 and angle 2 there, I think I might have some congruent triangles. My proof might include angle Y and A being equal, because that's given, and yt being equal to at, which is given. If it's not already marked on the picture, I should mark it to interpret what I have going here into here. And then I might say that I have some vertical angles. Now, right now, I'm looking at angle, side, angle. And that gets me well on the way to the end of my proof here. I have the two triangles marked congruent, and as you can see here, I'm trying to prove yp equals ar. Yp appears right here, yp and ar, so they correspond, so yp equals ar because of CPCTC. Hey, nice job. So it's about choices. When we're given three of these side lengths, we don't really have a choice as to how the triangle is shaped. When we're given an angle between two sides, it's the same story. There's my length of my sides, and there's my angle. I can't decide what that triangle looks like now. What I can do is connect the dots for the third side. And if I had a side between two angles, I don't really have a choice as to where these two angles meet. They'll just meet wherever they meet as we continue to draw them. And I can't change the shape without changing one of the values that was given. Think about this. Are these two congruent? Are they congruent by angle, side, angle? And what can you conclude about angle 1 and angle 2? Since angle 1 is congruent to angle 2, these triangles must now be congruent by angle, side, angle. You can try those classroom exercises. This is an optional thing to get you started. That's the end.